done bar modeling and real world problems with whole numbers, and now we're moving into fractions and decimals and kind of correlating that to how it fits in the real world. So this is kind of, if they have some struggles on homework, to be able to give you a solid foundation of understanding of what to do. So if we want to understand kind of what the 5th grade math curriculum is all about, what we're doing is we have operations and algebraic thinking. We do our numbers and operations in base 10. Now, right now we're getting into the fractions, measurement and data, and then geometry. And then how this book is set up is that all these things are working together. So you start by kind of just learning the foundations and learning the central stuff about, what are the operations of base 10, what are fractions. And then we put all those together and we work into problem solving. And so when we get into those real world problems, that's when we start having to kind of organize our thoughts and kind of picking out where things go. And so how do we solve these problems? Well, we use bar models. I know back when I was in school, we might have done like linear equations or kind of doing things like that. But now we have bar models. And it's just kind of a way to pictorially represent what do I need to know and what do I know. And it kind of helps the students, once they start doing them more and more and they get this negative connotation about bar models out of their mind, kind of just be able to see where do I go from here. So really there are 3 main types of bar models. The first bar model is a part-part whole. Now a part-part whole bar model is going to be a bar model that is used a lot in addition and subtraction. If you have both parts, you would want to know what is my whole. So for your part whole, when you have both parts, you want to end up knowing what is my whole, so you would add your 2 parts. With subtraction, you wouldn't understand or have your whole, and you wouldn't have one of the parts. So then what you can do is you can take away that part to figure out the difference between your whole. Sometimes at a part whole, you can have part whole. It just kind of depends on, what is going on in the story problem. If you go to the store and you buy 3 apples, 2 oranges, and 5 watermelons, what is your total? So you would have, each of your parts put together in a bar, and then you would kind of label it with a question mark. So that's another thing that we have them do, is when you start getting into these bar models, is labeling with a question mark, what do I need to know? What am I trying to figure out? That's the part whole. It's probably the most basic and the simplest of the bar models. The next one is a compare bar model. What you'll usually find when we have compare bar model problems is like Susie is this tall, her brother Fred is this tall, and Tom is this tall. You're kind of comparing different people or different values, things like that. And so what you kind of end up doing is you want to make the parts equal. One thing that we always are working on, and we always do math in this pencil, because you're going to be erasing and making parts equal. So with the compare bar model, let's say that I had Joe and then I had Tom, and Tom has this much, and I want to know what is that. So if I figured out my information, I could from there figure out the difference in this compare bar model. With the compare bar model, you're usually going about 3 values are going to be compared. And like I said, you'll find they're comparing 3 people, 3 brothers' sizes, different things like that. And then the last one is an equal parts bar model. And this is going to be your kind of one where you're putting things into groups, or you have your groups and you want to know how many you have in all. So this is going to be kind of your division and your multiplication. So if you had your whole and you know how many there are, so let's say there was 25, and you knew that you were putting 25 watermelons into 5 groups, well, your question mark would be how many are going to be in each group. So then you would do 25 divided by 5, and you would figure out your question mark. One thing that I'm always telling the kids is the label. Put that question mark on there to figure out, what do I not know? What do I need to know? And a lot of the times, and what we're getting into with our 2-step story problems, is that you're going to have to do 2 bar models. And like we'll see on this first example that we'll go through, you're going to need to end up doing 2, and then you could almost do 3 bar models with this one. So those are the 3 main bar models. They might seem a little hazy right now, but we're going to make sure that we get to some examples for all of them. So this is from lesson 2.7. I believe all the classes probably hit on this. This was back when we were just doing place value and your basic multiplication, your basic division problems when we went into these problems. So Mrs. Brandon had 230 soft toys. She kept 50 soft toys and distributed the rest equally to 15 children to sell for charity. Each toy was sold for $20. How much did each child collect? I always have the kids read them twice. That way they can start to, on that second time, kind of underline, okay, this is my first step, or this is the first thing I need to understand, or this is the first part I need to draw a bar model for. So if we were to read this again, it would say Mrs. Brandon has 230 toys. She kept 50 soft toys and distributed the rest. So the first thing that I want to do is I want to draw a bar model for how many toys Mrs. Brandon has. So, do I know my whole? 230. Now, she's taking some away and to keep some for herself, so that would be taking some of the 230 away, and do we know it's 50? So this goes back to bar model 1, the part whole. We know our whole, we know the part, and we don't know the other part. So therefore, from what we've learned about bar models, we would be doing subtraction, which, you know, us as adults would say, okay, she's got 230 toys, she keeps 50 away, she has 180, right? So she has 180. And that's our number that we're going to be kind of considering our whole for this next part. So she does something after she has that 180. What does she do? She distributes the rest equally to 15 children. Now, if we think back, what was the one that was distributing and putting things into groups? That would be our equal parts. So we know that she has 180. Now I'm going to keep my bar the same size as that one above it. Sometimes when you run out of space, or things don't always work out, you might just do a bar model somewhere else or move this bar somewhere else. But I like to try to kind of keep them underneath to keep myself organized. So right underneath she has 180. Now this bar is still 180. And she's distributing to 15 kids. So I'm going to divide my bar into 15 equal parts. Now I'm not going to draw 15 equal parts. I'm going to draw, this is how I always show it to kids, I'm going to draw a couple of them, and I'm going to write that number 15 to represent that there's 15 equal parts that have been divided in my bar. So where would my question mark go? It would go in one of those parts. I want to know what one part is equal to. So then if we did do that math, we would be doing our whole, 180, divided by 15, the number of parts. Anybody know that number?
12.
12. So then one part is 12. Now this is usually kind of where kids might mess up, because what does that number 12 mean? What does that number 12 mean? Well, if you've gone back and like I did, when I underlined, okay, I'm here, now I've done that. So now I've just figured out how many toys each kid's got. 15 children, they each got 12 toys. And now the next part says that they sold the toys for $20. So then I would take that number 12 times. So your answer would be $240. Each kid gets 12. If we wanted to do that part, you would have each kid do 12, and then there would be 12 equal parts that each equal 20. So then you would do 12 times 20 to get your whole.
Okay, but I just want to make sure I understand. He needs to do
the bar graphs until he understands then where to go from it, or will you look for a bar graph for each?
I'm not grading the bar. These are for his benefit.
His understanding.
And his benefit to, okay, so I was
no
here,
right or wrong.
now I'm moving here. Now, if you understand that each kid got 12 and they were sold for 20, so you take 12 times 20, but then you could also do the next bar model where there's 12 parts for 20, and then you don't know your whole. So that one kind of has all of the bar models in it. This one is from lesson 3.7, which my class is specifically on. In a day, Jamal spent 1 2/3 hours watching television, 1 4/5 hours taking an afternoon nap, and 7/8 hours helping his mother with housework. So if you wanted to just draw each of those parts, he spent 1 2/3, and then I would label that with a T for television. He spent 1 4/5, so you want to draw that a little bit bigger. 1 4/5 taking a nap, so I'm going to label that with an N. And then 7/8 hours with his mother on housework. So this one, it's a little bit simpler because right now you're just kind of working on, finding the common denominator and figuring out what to do. But if you want to pictorially represent this one, you would kind of have your 3 different parts. And from there we can kind of see, okay, this is what, and it's just a way to get organized. So the first question is, how much time did Jamal spend watching television and helping with housework? So we could pull out television and we could pull out housework. So that would be 1 2/3 and 7/8. And then from there, your student should know, okay, if I'm adding them, how much time combined I would find common denominators. And that's what we're learning right now is, to add and subtract fractions, you find common denominators. So then you would label your answer, so many hours. And then the next question would be, how much more time did Jamal spend taking the nap than helping with housework? And your student should be understanding that the vocab word, how much more, would have them subtracting. And then so you would pull out your nap, and then you would pull out the housework, and then we know now you find your common denominators in order to add or subtract and to do the comparing. Any questions on that one? This one is, and this is where we start to get a little bit more tricky. Tony is given 9/10 of an hour to mow a lawn. He only uses 2/3 of the given time to mow the lawn. How much time is left? Whenever we start with real world problems, I always have them just draw a bar. You're going to be doing something with this bar. And so we have 9/10 of an hour. So our whole is actually going to be 1 hour. The whole is an hour. And his mom or his dad or his special person at home has divided his hour, and she has not given him the whole hour. She's only given him 9/10. So we need to divide or put our our hour into 10 equal parts. So that's just kind of setting up our problem and organizing our thoughts. He has an hour, but he was only given 9/10 of it. He wasn't given the whole hour. Now it might help for some kids to shade instead of doing the line. So of that 9/10, he only used 2/3 of it. So now we can see that there's nine equal parts. And so now we can do 2/3 of 9. What a lot of kids would try to do would be to do the 2/3 of 10, and then that was where, you know, some discord or some frustration might come in. But now we're doing 2/3 of 9, which we all know we can do 2/3 of 9. So if we do the 2/3 of 9, let me get a different color. We would do 1/3, 2/3, and then we would see that there are 1, 2, 3 parts left, but not of 9 of the whole. So it would be 3/10 are left. 3/10 of the hour would be left. And as, I know that I'm talking kind of my class, but I know that as we get into the chapter 4, we start talking about questions like this, want to know of the whole. And so your whole at the beginning was the 1 hour. He just happened to only get 9/10 of it to use totally. This one is going to be kind of using when we start getting to equations and writing and using letters as numbers, which is pretty awesome. You will see that we use a compare one here because we have Alyssa and we have her brother. So I know that I'm going to have Alyssa and I know I'm going to have her brother. So I'm going to label my top bar A and I'm going to label my bottom bar B. Now we don't know what Alyssa has, but we know that she has more than her brother. So I'm going to draw hers longer than his. And we do know that her brother has $15. Now it says that she has 6p. That's her number. And we'll learn about, using those letters as numbers. So her 6p is greater than his 15. So what we don't know would be from here to here. That's where our question mark would go. So she has some amount of money that is bigger than her brother's. That's why our bar is bigger than his bar. And we know that she has this amount. Now, I could have drawn my bars to here and smaller. So then we can write, our equation for that, which would be 6p. Oops. My right side of my board doesn't like to work. Which would be 6p minus 15. So whatever this would be, your answer would be 6p minus 15. Because then whatever number you put in for p will give you your answer. And so when we get into using letters as numbers and writing those equations, that'll make more sense. But I wanted to give you an example of how we can use that compare bar model, and where we put that question mark is huge. And then the last one, I know I sent this one home. This one gave lots of people fits. I think we went over up on the board one time or 2 times. It gave me a couple fits. But I think this is the one that really represents that having that bar model to help you is really, really good for them. So Jessica and Lillian had the same amount of money. Jessica gave $1,140 to a charity, and Lillian gave $580 to a different charity. In the end, Lillian had 9 times as much money as Jessica. How much money did each girl have at first? So we're comparing 2 people. So automatically we know that we need to draw a compare bar model. This one is going to be essential that we keep our equal parts equal. So I'm going to make Jessica on top, and I'm going to make Lillian on bottom. Now we know that they started off with the same amount of money. It tells us that in sentence 1. So I have them with their wholes being the same amount. Now, Jessica was the one that gave more money. She gave $1,140 to charity. So this would represent my 1,140. And then it says, Lillian gave $580. Now, I've left my bars kind of like that because I know the next part says that in the end, Lillian had 9 times as much money as Jessica. So Lillian had 9 times as much as Jessica. Well, we both know if she has 9 times as much, she still has one part that is equal to what Jessica has. We know that they at least have one equal part. So then that means this remaining slice right in here is going to be 8 more equal parts. So that way, Lillian would have 9 more equal parts. Now, because we know that they have one part equal, which is right here, and we know that she gave 580, so we know 580 of that 1,140. What we don't know then is what is here, or what is here from that 1,140 subtracting the 580. So then you would have to do 1,140 minus 580, and then you would get 560. So this right here is 560. Which you could see if you don't, if you pretend that that's not there, and you know that Jessica gave 1,140, you would know that since these parts are equal, they're both equal to 580. And so now we have 560 split between 8 equal parts. So then you would do 560, because I would want to know how much are each is this part. 560 divided by 8, which is going to say that each of them is 70. And if this is 70, then this is 70, and this is 70, and this is 70, but we also remember that this is also equal to this. So that means that this is 70. And if this bottom square is 70, then that also means Jessica's square is 70. And then when we go back to the original question, how much money did each girl have at first? Well, at first we drew that whole long bar model. And so it would be 1,140 plus 70. So your final answer would be $1,210. That one's a lot to take in, but it represents kind of all of what they should be able to do with the bar models. Comparing, putting things in equal parts, having kind of parts and wholes, and then being able to, where's my question marks go? Where can I put different things? I think that's my last song. Questions?